Assalamualaikum everyone, I am Noor Zainab, and in this video we're going to study about momentum. What is the relation between Newton's second law of motion and momentum? We will also discuss the impulse momentum theorem. Momentum is a vector quantity. The linear momentum of an object is the quantity of motion it possesses. It is the product of its mass and velocity. Momentum is the quantity of motion an object possesses, and it depends on the mass as well as the velocity of the object. Whereas the quantity of mass an object possesses is known as inertia, and it depends only on the mass of the object. Now let's discuss how Newton's second law of motion and momentum are related. The Newton's second law of motion states that the resultant force acting on an object with a constant mass is directly proportional to its acceleration. According to Newton's second law of motion, the more force you apply on an object, the more acceleration is produced by the object. The mathematical form of Newton's second law of motion is force equals mass times acceleration. As we know that acceleration is the rate of change of velocity. It is the final velocity minus initial velocity divided by the time taken. So by putting the formula of acceleration in the above formula, we get this equation. Here multiplying m with both final velocity and initial velocity, we get this. And as we know that the momentum of an object is equals to mass times velocity. So mass times final velocity is equals to the final momentum of the object, whereas the mass times initial velocity is the initial momentum of the object. In this way, we can say that final velocity minus initial velocity is equals to delta p. So here we get the relation between the force and the rate of change of momentum of an object. The rate at which the momentum of an object is changing is equals to the force which is acting on the body. Or we can say that the time rate of change of linear momentum of a body is equal to the force which is acting on the body. Hence we can say that force is equals to the rate of change of momentum of an object. So now as we have derived the relation between force and the rate of change of momentum of an object, if we bring time on the other side of the equation, it is we multiply force with the time duration, we get a new quantity, and this quantity is known as impulse. So in easy words, impulse is the change in momentum. Impulse is equals to the change in momentum which is caused due to a force F, which is applied for a duration time delta t. Furthermore, like momentum, impulse is also a vector quantity. It means that it has both direction as well as magnitude. And its direction is same as the direction of the force. Impulse is denoted by the letter J, and it is the product or the multiplication of the force and the time duration during which the force is acting. The SI unit of impulse is Newton seconds, which can also be converted into kilograms meters per second. So finally, now we can conclude the impulse momentum theorem. The impulse momentum theorem states that the impulse applied to an object is equal to the change in object's momentum. It means that the impulse is equals to change in momentum of an object. Furthermore, here are some key points to remember: that impulse is a change in momentum, whereas force is the rate of change of momentum. So now let's discuss the relation between momentum and kinetic energy of an object. Kinetic energy is the energy which is possessed by an object due to its motion. So linear momentum is given by the formula P equals to mv, whereas the formula of kinetic energy of an object is half mv squared. So now if we multiply and divide this formula of kinetic energy by mass, we get this. So here you can see that mass times velocity is known as momentum. So we can replace m square v square by p square, where p is the momentum of the object. Hence, this is the relation between kinetic energy of the object and the momentum of the object. So if you have been provided with the value of momentum of an object, you can find the kinetic energy of the object. So here you can see two main relations between the momentum and kinetic energy. These important relations show us that a body cannot have kinetic energy without having linear momentum and vice versa. If we analyze these formulas, we can see that if the momentum of an object is constant, then kinetic energy and the mass of an object are inversely related. It means that if an object has more mass, it has lower kinetic energy. Similarly, we can see that if the kinetic energy of the object is constant, then the momentum and mass are related directly, but the momentum is directly proportional to the square root of the mass. Lastly, we can see that if the mass of the object is constant or same, then the momentum is directly proportional to the square root of the kinetic energy. So here you can see all the formulas which we have discussed in this video. If you have any questions, you can ask in the comment section. Like, share and subscribe to this channel, and thanks for watching.